then the
Recording in
result is going to be
progress.
nothing but it is a tail. Else, that means if gender is not female, then the result is going to be nothing but it is an head actually, isn't it? So this is my insights actually, guys. This is what my machine will learn. If you give the same data to the machine, this is what my machine says it actually, guys. We don't write this code. Normally, if I ask you to write this code, we'll write the code like this. But we'll give this data to the machine saying that please try to find out what is the relationship between result and the gender. Try to find out the difference relation between the gender and the result. The machine says that I find it a story here. I find it a story here. If gender is equals to female and the result is equals to tail, else result is going to be head actually, guys. It is only just a two-dimensional data actually, guys. The main problem in the result in the real time is it is an higher dimensions data is there. It is an higher dimensions data is there. Actually, resulting the tossing the coin does not depends on any event actually on any factor, but we are talking about them, guys. For example, there is a gender is there. Not only gender, we have temperature column is there. Whether it was raining or not, whether it was rain or not, what is the temperature? It is cool. Is the rain is there? Is true. Is the temperature is hot, but what is going to be rain? It is false. Currently, the temperature is cool, but there is no rain is there. Every time the temperature is cool, it does not mean that it is raining actually. So there are so many factors we have been given, guys. Now we can't study them. Normally, as a human, we can't study them. So by applying some statistical formulas and by using mathematical theories, we can solve the problem. But instead of you solve the problem, give this data to the machine, guys. Give this data to the machine, guys. So to understand what is machine learning, I'll start with this kind of small examples only, guys. If I take a real data set and do them, I'm not saying that I'm teach you only small data set. We'll begin with a small data sets actually, guys. The data which we can generate with your normal, that means a normal data which you can generate. Like for example, the heights and weights of your family members. So I'll ask you to just collect. You can just collect the heights and weights of your family members. So collect your height and collect the weights. And you collect the gender also, guys. Collect the gender also. And give it to the machine. Machine is going to tell you there is some relation between gender, height, and the weights actually. So we know them. So generally females are going to be at a lower heights compare with that particular what we can say with the male heights actually. Their average is going to be a little bit more. Even the weights of females are going to be less than the average weights of that particular females. Just you can collect some 4 or 5 family members data. You can give it to the machine and you can ask the machine, can you find any story behind this particular data? It's a kind of a story behind the data actually, guys. What is the story behind the data only? It is going to tell you actually. So I understood this data. So the people who are having the weight more than, for example, it will tell some story like this, guys. If the weight is going to be more than, for example, 70 kgs, and for example, the height is going to be, let us say, more than, let us talk about in feet, for example. So in 5'5", it is going to be, then the gender is going to be nothing but it is a male. Else, it is going to be nothing but it is a female. Some kind of a short stories actually, guys. The machine will tell you this kind of a stories only what the machine is going to say that actually. What is your height? What is your weight? What is the gender? So if you want, you can do some kind of an example, guys. Collect 3 or 4 family members. You can collect. So at least you can collect 3 members or 10 members, you can collect it. Some of your family members or your neighbors or your friends or anybody relatives, you can collect some data actually, guys. So we are only generating the data, guys. The research people will be there. What the research people will do actually, guys, they will have their research data. Whatever the data is, the research people may be there, or it may be business people. They have their business data. Research people generates their own data actually. Let us say that there is a research associate is there, or a research organization is there. They are trying to do some research on the heights and weights of, what is meaning of a research actually, guys. Research means just trying to understand how that particular is happening. Is there what we can understand from that particular data? Research is nothing but they do this kind of an analysis only. So they collected some 1,000 people's data and they want to do some kind of an analysis. So what are their heights? What are their weights? What are their genders? You can just collect some data and we can do them actually, guys. If you want, I'll show you some practical, simple example in the today's class to make you just understand how this is going to be gets working actually, guys. Okay. So what basically this particular is going to be means that I'll show you just to understand them, which is going to be nothing but what we are going to call it as, what we are going to do that actually. So give the data to the machine actually, guys. Give the data to the machine. Machines can understand the data and machines can tell you what is the story behind the data. But basically, whenever we are going to be working with the higher volumes of data actually, guys, when you are going to be working with the higher volumes of data, or whenever we are working with the higher dimensions of data, actually, we are trying to find out the relation between height, weight, and a gender. Only three different dimensions only we are going to be working. So three-dimensional data actually, guys. So anyhow, I'll let you know about that. Why it is a two-dimension, why it is a three-dimension actually, guys. So whenever we map this, just a minute, guys. Anyone is there, guys? I think anybody's video has been started. I'll get the notification. I think, yeah, fine, guys. So, okay. So what we are talking about here is, it's nothing but if this data is going to be mapped to a free space actually, guys. So for example, if I talk about height and a weight actually, guys. So it is going to be, if I take only height and a weight, it is going to become say two-dimensional. So this is going to be height and this is going to be weight actually. So let us say we can see the data actually, guys. Some data is going to be there. Just an example. Don't worry about them. We see some data like this actually, guys. Some data is there. Does not matters with that. So being it can be mapped to a two-dimensional space, we call it as a two-dimensional data. So normally we all of you know this, guys. Two-dimensionals we can visualize. Atmosphere we can use a three-dimensional, guys. Even you can also visualize three dimensions, but you require a little bit effort. Beyond the 3D, we can't visualize with our normal screens. We know them. We know them in our normal screens. We cannot visualize more than that actually, guys. So we can do a three-dimensional representation. We can do it actually, guys. I'll show you. If you want, I'll just show you some small data set with a three-dimensional space. I'll show you. Two-dimensional, three-dimensional. Generally maximum, guys, two-dimensional and three-dimensionals, we can visualize them. Beyond that, we can't visualize. We require some kind of an higher. That means these devices are not sufficient. Whatever the laptop screens we are using or whatever the desktop screens we are using them, we cannot visualize them. For that, we require separate graphic devices are required actually, guys. We require a separate graphic devices are going to be gets required actually, right? Isn't it? So that is the reason why we are going to be using this kind of an applications actually, guys. This is going to be what we are going to be doing, what we are going to be gets working with them. So don't worry. It is just, I'll show you one small, that means just, you may be just interested with that. That means how it is going to be gets done. So don't worry about the code actually, guys. Don't worry about the code, what I'm writing. It is just to make you show really is the machines will learn or not. Just a small idea about the data actually, guys. A very small idea about the data actually. This is going to be my Jupyter notebook actually, guys. This is my Jupyter notebook. Okay. I'll tell you how to get this Jupyter notebook in your system. Don't worry about them, guys. So I'm going to be importing a small module called as an pandas. Pandas is basically, guys, to prepare to work with the data frames. We are going to use the pandas. Don't worry about the code actually, guys. Don't worry about the code. I'm just showing how easy to make the machine to learn actually, guys. I'm preparing my own data frame actually, guys. This is what I'm going to call is a data frame. Data frame is nothing but a tabular structure actually, guys. Just very simple. What is going to be the height? Just I'm writing it as an height, guys. Okay, what are the values? What is going to be the weight? What are the values? What is going to be height and what is the weight? Okay. And after that, I'm going to be saying that it is going to be the gender actually. Just I'm preparing some data actually. So we are preparing some data actually, guys. Actually, we can do one thing. You can put it in an Excel sheet or a CSV file and you can import it. I'm preparing my own data actually, guys. Okay. Let us say that some height, let us say that I'll put it in centimeters actually. Just some random data only I'm preparing actually, guys. Let us say 172. Let us say which is going to be 170. Let us say 156. Let's just an example, guys. I'm not biasing anything here now. Okay. So just to make my model to make you understand easily, I'm just giving some biased data actually, guys. Biased data means it will take some conclusion. We can't take such kind of a conclusions directly. Let us say which is going to be 165. And let us say that it is going to be 160. Just an example actually, guys. What is going to be their weights actually, guys? Some weights in kgs will take it actually. Let us say 72, something like an 75. let us say something like a 65 or something like this, and something like an whatever it may be, 68 or something like this. So total 5 people are there actually, right? And it is going to be, let us say 80. So coming to the gender actually, guys, I'm taking the genders like, let us say it is a male, and let us say it is an another male actually. Okay. So I'm not making any bias here, guys. So don't say that I'm making some bias statements here now. It is going to be female. And this is going to be, let us say that again, it is a male. And then I say it is a female actually. Just I prepared my small data set actually, guys. And this data, I'm going to be putting into some data frame. It's what we generally call it as a data frames actually, guys. So just if you can see, this is my data preparation actually, guys. I'm preparing my data actually. See how easily I prepared the data. A tabular format. These are what we call it as data frames. In real applications, we don't prepare the data like this, guys. The data will be there in an Excel sheet or a CSV file. From there, we are going to be extracting the data actually, guys. Okay. So this is going to be what we are going to be doing this application, guys. Okay. Don't worry about them. It's a very small data set actually, guys. It's not like your previous case, guys. It's not like your previous case. It is not a direct data, but up to some extent, we can understand the data actually, guys. Who is going to fill the Excel sheet? No, we don't fill the Excel sheets, guys. Excel sheet is nothing but your business data. Your business data. It may not be an Excel sheet. We'll have your business data. You have a research data. They will generate the data. No, machines data will be there. So we are going to be just working with that particular data actually. Okay, fine. Now have a look at this one, guys. This is the data I have to give it to the machine actually, guys. But there is going to be some process will be there, guys. Directly if we give the data, it is not sufficient. We have to give the data in a proper format actually, guys. Okay. So this is going to be what we are going to be have the, okay. So this is the data what we have to give it actually, guys. Okay. So this is going to be what we are going to be doing. This is the work what we have been got done, guys. Now this is the data I have to give it to the machine. Don't worry about them. Actually, what is my main target actually, guys? That means I'm trying to analyze with the help of the height and the weight. Can you identify the gender? So what is your identification? What you want to find out? I want to find out the gender based on what? Height and the weight actually, guys. So generally, the what you are trying to find out, that is your target. What is your based on what factors you are trying to do that? That is going to be nothing but your dependence, the independent features, what we call it as. Don't worry. These are the features, guys. And these are your labels. The features. What are the features? You know what are the features actually, guys? Characteristics. So these are the features. I'm giving the features like this. What is height and what is weight? Based on that, what you want to try to predict. That is going to be what we call it as gender actually, guys. So don't worry. For this, I'm going to show you. Don't worry about them. I'm just showing you some small machine learning algorithm, guys. How do you implement a machine learning algorithms, guys? Everything is in predefined functions will be there. We really don't write any code actually, guys. From sklearn. Just a small application, guys. This is, yesterday I told about some algorithms actually, guys. I'm applying a decision tree algorithm, guys. From sklearn.tree, I'm going to be importing a small function called as a decision tree classifier. Don't worry about the code actually, guys. I just want to show you how easily the machines are going to be learning actually. So the data is also very easy, guys. If I just put a small effort, we can see the data. All the males are having height more than, which is 160. More than 160 is going to be nothing but males actually, guys. And also we can identify the weights also. Just a small data have been given, we'll verify them. sklearn.tree, import the decision tree. Don't worry about them, guys. I'm just creating an object of a decision tree classifier. Don't worry about them. Very simple actually, guys. Just we have to give the features and we have to give the variable, the label we have to give it actually, guys. Yes, we'll see them. Absolutely, we'll see. Yes, Shiva, we'll see how to extract the data from data. Everything is possible. It is done only by using this pandas concept only, guys. Do you want to read the data from a table actually, guys? It is going to be nothing but these are the options actually, guys. If you want to read the data from any SQL query, so there are so many options are going to be there actually, guys. This is going to be how do you read the data from an, which is going to be by using some an SQL data, how to extract the data from a database systems. Okay. So this is what we are going to be doing. CSV files, Excel sheets. Okay. We work with JSON files. We work with SAS files. We can work with Stata files. So many options are going to be there actually, guys. We'll see them. Okay. Fine. Now see guys, don't worry about them. What is the features actually guys? So we are learning the techniques, how to represent your data guys. Once you represent the data, machine will take care about them. You really don't worry about them. So this is your data frame actually guys. What are the inputs I'm giving actually guys? Your input is height and input is weight. What is your output actually guys? Your output is going to be nothing but I said it is a DF of which is a gender actually. That's it guys. This is the code what my machine is going to be doing actually. This is machine learning actually guys. Over. My machine has been learned actually guys. Only 3 steps. I just imported the function. I created the object of the particular classifier function and I have been done the training actually guys. Over. Machine has been trained. So if you want to see what the machine has been learned guys, I'll show you the data actually. Let me show you the data. Don't worry about them. I'm going to show you one small data actually guys. What the machine has been learned. If you want to see, I'll show it in a different formats. I'll show you what the machine has been learned. Observe carefully guys. I didn't written any functional code. I just prepared my data and I given the data in a proper format. So these are your features. This is your what you have to find out. So try to understand the height and the weight for predicting the gender column. I want to analyze the gender based on the height and the weights actually guys. Don't worry about them. It's a very simple and very easy option actually guys. What is export underscore text? I'll show you guys. Don't worry. What is this export underscore text? CLF comma, just don't worry. Your feature names is equals nothing but I'm saying that it is height and it is a weight actually. Don't worry about the code actually guys. It's only just not a functional code actually guys. This is going to be nothing but the result. The result equals to, as I told you now guys, machine is going to write the program, print what is going to be the result actually. I didn't return any functional code guys. I didn't return any functional code guys. Can you see? If the height is less than or equals to 160.50, 162.50, it is a female. If height is more than 162.50, it is a male actually. That is what the story, what my machine is saying that actually guys. If this is what machine learning guys. That's it guys. This is machine learning. But being the data is a very small data, we didn't done any much pre-processing. I didn't done analytics. I didn't done any analysis. I didn't done any cleansing. Nothing have been got done. Data is completely in a clean format is there. So I given the data directly to this. Can you see? It is saying that this is a story, what I can say that. If you want, I'll give only the weight. Can you find it off? Yes, I'm giving only the weight only. Based on the weight only, you try to do some analysis. Yes, that also it is going to do this result actually, guys. Can you see the application, guys? More rules we got it actually. If the weight is less than or equals to 66.50, it is a female. Check it out. Less than 66.50, yes, it is a female. Right. If it is more than 66.50, observe carefully, guys. If it is more than 66.50, I can't say that it is a male because we also have a females are also there actually, guys. We also have the females are also there. That's why it is saying that is the weight is less than 77.50. That means if the weight is more than 66 and if the weight is less than 77, then it is going to be male actually. What are the female weights actually, guys? It may be less than 66 or it may be more than 77.50. It prepared that particular model actually, guys. That is my model actually. I didn't return any functional code. It's like an if statement actually, guys. If weight is less than or equals to 66.50, the result is a female. Else, if the weight is more than 66.50, I cannot say that. If the weight is less than 77.50, then the class is a male. Else the class is going to be female actually. That is what exactly the machines are going to be learning actually, guys. Yes, what criteria we have to use it. It's not like this data is a very smaller dimensions data actually, guys, right? It's a very smaller dimensions data. When the data is going to be higher dimensions, so first of all, what is our work is really the gender is depending on the height or depending on the weight or really depend on both height or weight. We have to find it off actually, guys. This data is going to be very small data. And we already have a domain knowledge, the height and weight. Using that, we can find the gender. But when you go to real applications, when you talk about a business attributes, how do you decide it actually, guys? For example, how many transactions a customer may do? How many transactions a customer may do actually, guys? How many transactions, like I say, banking transactions. So we are having, is it really depending on, there is a column called as in children. How many children we are having? So is that depending on the number of children? Is the number of children is deciding the banking transactions? We have to find the relationships. You have to find the relationships, guys. Machines can't find the relationship. Machine always thinks that, in this case, guys, machine always thinks that the gender is depending on the weight, or the gender is depending on the height, or gender is depending on both height and weight. But machines does not knows that. We have to decide, is the height is deciding the gender, or really the gender is depending on the height? That is what we have to study. When you go to business attributes, we can find a lot of attributes, guys. We can find a lot of attributes are there. So by doing some analysis, we have to do this actually, guys. What is that extra 0.50 means? Some cutoff values actually, guys. There are the boundaries. It is going to be boundaries. So you're expecting that less than 66 must be something like that. But it is saying that it creates some boundaries. There is a mathematical solution is there for that. There is going to be internally some mathematical calculation is going to be going on. Based on that mathematical calculation, this is going to be doing actually, guys. So if you can see, this is called as a decision tree algorithm actually, guys. If you want, I can show you this in a tree format also. I'll show you in like a tree format. Have a look at this. I can show you in a tree why it is called as a decision tree actually, guys. Why the name decision tree has came. I can show you some small tree. The same data, I can show it in a tree format. I can show you guys. Same data. I'll show you the format like this actually, guys. Like this is a tree. What is my tree here is like this actually, guys. If the weight is going to be less than or equals to 66.50 in a tree format actually, guys, then if your answer is yes, then it is going to be female. If your answer is no, like this actually, guys, just like a branching of trees actually, branching in a trees, then is the weight is going to be more than 66.50. If your answer is yes, what is the class? If answer is no, what is the class? If your answer is going to be greater than 66.50, then immediately I can't say that. Again, one more condition. If it is going to be weight is more, if it is S, then you are checking one more condition actually, guys. Is the weight is less than or equals to 77.50. If your answer is S, then it is going to be nothing but it is a male. Else it is going to be nothing but it is a female actually. Like that, we are going to just prepare some kind of a tree like this actually, guys. We are preparing a tree like this. If you want to see the tree, I'll show you the tree. The tree has been prepared by the machine. We are only plotting it actually, guys. We are not doing anything actually. Don't worry about them. So yesterday somebody has asked me, so what is the purpose of this particular plotting actually? Let us do one thing. Let us make it as only based on the weight only, guys. Okay, don't worry about them. What is the code I'm writing? Don't worry about them. Okay, so what is going to be my feature names actually? Your features are going to be nothing but weight. And what are going to be your class names actually? Your class names are going to be two class names. One is nothing but female. Is it female, right? Yeah, it is female. And the other one is going to be nothing but I said it is a male. Just see don't worry about the code actually, guys. See the beauty of this particular functionalities, guys. See the beauty of this particular functionality, guys. It is going to be, can you see, weight is less than or equals to 66.5. If your answer is S, then it is going to be female actually. If the weight is more than 66.5, then come here now. Then check it out. Is the weight is less than 77.5. If your answer is S, then it is a male. If your answer is no, then it is going to be female. The rules are going to be something like this actually, guys. You can add a lot of beauty to this actually. There are multiple techniques are there. So you can say something like what is going to be Gini. So that is a Gini is what exactly we have to talk about then. How this splitting is taking place actually, guys, by using something called as a Gini index. We have a different criteria are there. So let me show you. Criterion equals to, I have a Gini index. Gini is there by default. Otherwise, we have an entropy calculation is there. We use entropy calculation. Then it is going to show you the entropy in the place of the Gini index. Previously, we have seen Gini. Total how many samples are there? Easily you can understand them, guys. Total how many samples are there? 5 samples. Out of the 5 samples, 2 females and 3 males are there. So when the condition less than or equals to 66.5, 1 female came here. So another female left over here now. So that 1 female and the 3 males has been left over here now. Now again, I'm splitting. Is the weight is less than 77.5. Then all the 3 males has been came here now and the 1 female go here now. Just by using this, we can take a decision. Now, how can you do this, guys? Tomorrow, if I give a person whose weight is going to be something like, for example, 74 kgs is there. So what is going to be the gender actually, guys? Easily we can do that. 74, come here. Start from here, guys. Is the weight is less than 66.5? No, come here. Is the weight is less than 77.5? Yes, come here. It is a male. So if the person weight is going to be 74 kgs, we say that it is a male actually. If it is going to be 78 kgs actually, guys, then what we'll say that? His weight is less than 66.5? No, come here. If the weight is less than or equals to 77.5? No, come here. Then in that case, I say that it is a female. Like that, we are going to work with this. It's a very short story actually, guys. It's a very short story actually, but still the machines can understand them. Machines can understand them, guys. So I didn't done any coding here, guys. I just prepared my data. I just given the input, only some instruction. Instruction means what is my features? What is my features? What is my target? If I give the height, then it is saying that this is going to be my values. I'll write it as an height actually. Remaining thing remains the same. Execute. This is the train actually, guys. If the height is less than or equals to 162.5, yes, two females are there. If the weight is, if the height is going to be more than which is going to be this value, then it is going to be male actually. Less than 162.5 is a female. More than 162.5 is going to be nothing but males. Some kind of generalizations will be done actually, guys. So don't expect that directly less than 160. Some kind of a generalization will be done actually. How this generalization will be done, that is we'll see whenever we work with this particular concept. So what is this entropy? That is what we have to study about them. Okay. So what is that particular entropy? We'll study them. So this is how we are going to be working with them, guys. Right, guys? So this is a basic idea about how the machines will learn actually, guys. So you may be wondered about, you may be wondered about, real machines will learn? Yes, absolutely the machines can learn, guys. Now, if you want, we can ask some data. If I give you the weight, can you predict it? Yes, machines can predict actually, guys. So based on these rules only, we do the predictions actually. I'll give some weights. So I'm going to give the weights actually, guys. Let us give the same weights. Whatever the weights I told you, 74 and 78. I'll prepare my data actually, guys. Some data I'm preparing. Just nothing is there. Don't worry about them. I'm only giving only the weight only, guys. I'll give only the weight. The machine will tell me the gender actually. Some DF, let us say DF1 is equals to, don't worry. It is PD dot. It is a data frame. Only height, sorry. We have been prepared only by using height only, no? Okay, I'll give only the heights actually, guys. So don't worry. I'm preparing the heights actually, guys. Height. And I'm going to say that, or a height or weight. Okay, I'll go for a weight actually, guys. Better. So let us say that this is a weight actually. Currently, I'm training my machine based on the weight, not based on the height. Okay, I'll give the weights actually, guys. So then I'm going to say that it is a weight. Same weights I'll give it actually. What are the weights actually? 74 and 78 kgs actually. I'm giving the two values. 74 and it is going to be 78. That's it. This is our data actually, guys. If you want, you can see the data. My data is containing only the weight. Now I'll give this data to my model and ask my model to predict the data. What is my model name? CLF dot. It is a predict. I'm going to give the DF1 over. The machine is going to predict the labels actually. So 74 kgs is a male and 78 kgs is a female actually. If you want, you can give any data actually, guys. 67 you give it actually. According to the rule, if it is less than 66.5, it is a female. If it is more than 66.50, it is going to be male actually, guys. You can see that. So now it is going to be 67 is a male actually. If I give 60 kgs, then according to the rules, 60 kgs means it is going to be female actually. So 74, 67 is going to be males. 78 and 60 is going to be nothing but females actually. Can you see? My machine is predicting actually, guys. 2 males and 2 females it is there actually. That is what we are going to do that. So got the idea, guys? What is meaning of a machine learning? How it is working actually? Don't worry about the code actually, guys. We'll discuss all these things practically in our real applications with our actual classes. What is this entropy? Applying an algorithm is very easy, guys. You really don't really need to write a code actually. Really no need to write any code actually, guys. Sir, what is this code? This code is just only we are giving some inputs and getting some output from the machine. But internally, the work is done by the machine actually, guys. Machine developed these insights. Machine developed these insights. Machine developed these insights. A simple example, guys. A simple example. In your mobile, when you want to take a photo, so where is the face detection is done? That is a machine learning algorithm actually, guys. That is not a big thing, guys. You can do very easily. Where is the face is located? If you want, you can see it, guys. So for that, we don't write any code at all. For that, we are going to be having some libraries are going to be there actually, guys. The library name is going to be what we call it as an FER, face emotion recognition actually, guys. FER. It's a face emotion recognition. It's a deep learning model actually. It is going to detect where is the face is going to be there. Just give the image. No need to write any code. How to give the input image to the machine? That is what I am going to explain you here. So we are learning only that particular data processing and internally how to prepare the data and how to train the model actually, guys. So if we just give the image and the machine directly tells you where is that particular face is going to be there. So drawing the rectangle, we have to do it by ourselves. It will not be done automatically by itself. We have to do it manually by ourselves, drawing the rectangle. But where is the face detection is there? What is the location? What are the coordinates it is going to tell you actually, guys? A very simple code, a very, very simple code actually, guys. It will tell you where is going to be the location, the coordinates of that particular face. And even it also tells you the emotion actually, what kind of an emotion it is showing you. A sad face of 27%, a surprise of 41%, and it is going to be neutral is going to be 9%, angry of a 2%, something like this. So somebody is asking me, will you discuss about the computer vision projects? Absolutely. We are going to be learning all these computer vision projects actually, guys. We are going to do that. We have a code actually. I already having some code with me. That means coding means generally for practical purpose, we are going to, that means for a demo purpose, we are going to show them actually, guys. It is going to be nothing but we are having one FER, which is going to be IP1B file. So this is just the code what I have been written actually, guys. Nothing code is going to be there actually. It's a nothing code is there actually, guys. If you want, anybody can try the example. Anybody can try this example, guys. If you want, you can send your images. If you want, you can send your images. Not now. In our regular classes, we'll see them actually, guys. We'll ask our participants to send their images actually. Okay, with the different emotions. I'll show you the emotions actually, guys. So that's it. This is a code actually, guys. Nothing I've written the code. Just I imported the image. I just imported the image. Can you see here? FER module, Opencv module actually, guys. So all these are going to be done with the help of Opencv. There is an Opencv module is there, a very popular for computer vision projects actually, guys. We work with this particular Opencv. We are going to be working with something called as an Yolo. So all these are some of the open source libraries actually, guys, which we are going to be using working with these particular applications actually. So many applications are there actually, guys. We are going to work with them actually. Okay. So this is going to be some of the libraries. No need to write anything, guys. Some of the libraries what we are going to be using actually. Apart from that, we are going to be having something called as Yolo. Even Yolo is going to be another open source actually, guys. A computer vision projects actually. Okay. So these are going to be some kind of an object detections. It's very easy actually, guys. You may be worried about, you will see some lot of examples actually, guys. There is a traffic image is there. It will show you all of them as a cars, bikes, etc. That is not a big project at all, guys. It's very easy whenever it comes to our Python. Whenever it comes to your deep learning, all these are going to be very easy applications actually, guys. Okay. So I think so. It was done. Okay. Just for a small timing, don't worry about them, guys. I'm just showing some image actually, guys. This is an image, a smiling image actually, guys. Where is the face was there? I'm just going to find the face actually, guys. The system will tell me where is the face location is there. Using that locations, I'm going to be drawing the rectangle around the face actually. So you can see some rectangle, red color rectangle has been drawn actually, guys. You can take multiple images. I have multiple images with me. Just for testing purpose, I given them. I have a lot of images actually, guys. A lot of images are there. So let us say that there is a female image is there. This is my female image. So in every image, the face location will not be the same. The face location will be dynamically detected actually, guys. In this image, this is located here actually. Or we are having some other face actually, guys. Just I'll show you one face. We are having some kind of an angry face is there actually. We are having an angry face, a boy who is a very angry actually. So the image is going to be the face is located at the end of this on the left hand side of the image actually. In the earlier two cases, it was there at the middle. So I'm giving to the system. System will tell me where is that particular, where is the face is there actually. With that, I have been drawn this particular rectangle actually. That's it, guys. This is the code what I have written actually. I didn't written any functional code. Everything is done by these functions only. Find the face. Tell me the face, where it is located. It will tell you. It also tells you what is an emotion also, guys. It also tells you what emotion that particular face is there. You really don't require to write any particular code. So that is going to be what exactly we are talking about them, guys. Okay. This all comes under computer vision projects, and we are going to be working with them. Okay, guys. So that's it for this particular, the demo class actually, guys. So yesterday I told you about some aspects, some technical aspects of what is going to be machine learning, what we are going to do. And today, what are main issues actually, guys? Simply, if you give the data to the machine, machines can't study them. Machines can't study them. Really, it is learning correctly or not. Machine does not knows about that. So we are the people who has to decide actually, guys. Is really gender depends on the height? Is really gender depends on the weight? That is what we have to decide. Machines can't decide them. If you decide, the machines will do it actually, guys. Same example I shown you like earlier case, no? Heading, the tossing the coin, head or a tail. If you ask the machine, so can you find out the relation between gender and that particular result of a tossing the coin? If there is a rules are there, it will tell you the rules. These are the rules what I find it out. Otherwise, these are the rules I have find it. These are not correct rules. These are going to be accurate rules. These rules are 100% correct only, guys. There is no errors in these rules actually. 100% there is going to be. If the end value entropy becomes 0, meaning that it is inaccurate. So entropy will decide how accurately the model is working. We can decide them actually. Got it. We can ask the score. What is your score? It will say that my score is 100%. CLF dot, I can ask my score. What is your score actually? So when I give the same input to the machine, my system is going to tell you the score. Currently, my score is 100%. It is going to be a value between 0 to 1. Tell me what is your score. 100% was accurate. 100% these rules are correct actually. Sometimes some rules may goes wrong. Then it says that 98% correct, 97% correct, 80% correct, something like that, the data will be there. Got the point, guys? So that's it, guys. That is a basic idea about how we are going to do the machine learning. So don't worry about the code actually, guys. It is just to make some interest in the topic. I just added some code, but really don't worry about them. All this code we are going to see in our real classes actually. Okay, fine. Overfitting is nothing but whenever the model is working, actually, I think, I don't know how much extent you have it actually. Generally, we are going to train the model on our train set, and we are going to be test it on the test set actually. So training and testing, what we are going to call it as. We split the data into two parts. One is a train and one is a test. So whenever the train accuracy is very, very high, and whenever the test accuracy is going to be very poor, that is going to be what we call it as overfitting. Like example, just to make you understand that there is a job with a 2 years experience is required. So there is a job requirement is there, which is having 2 years of experience. But a person has got with 12 years of experience. That is what we have called it as an overfitting. That is what the overfitting in machine learning. That means it learned more and more, but his performance requirement is very, very less actually. So train is more. He is having 12 years experience. But from there, I'm going to be using only 2 years experience only I'm going to be using actually. You are overfitting. Same as it is, models are also, your machine learning models also will leads to overfitting actually. So how to avoid the overfitting actually? Mainly in decision trees, we have that overfitting problem actually. So what are the techniques to avoid the overfitting? That is what we'll learn in our actual classes. Okay. Fine, Shiva? Fine. So we have an overfitting, we have an underfitting. So we have some kind of an balanced, some kind of an terminologies will be there. Fine, guys. So that's it for the today's class, guys. That's it for the today's class. And my backend team is going to share you the details actually, guys, all the details. Okay. And as people is asking about my course curriculum, guys. So this is going to be my course curriculum actually, guys. Okay. Let me show you. This is my course curriculum actually, guys. Yeah, guys. So this is going to be my complete course curriculum application, my complete course curriculum, guys. So this is going to be the first one, which is going to be the duration, guys. So where we'll start with our core Python, guys. All topics will be covered. So completely core Python. We are going to learn some around 12 to 15 days, guys. We written approximately 12 days, but it takes 12 to 15 days. So NumPy, next we are going to start with the NumPy, guys, which will take some around 5 days. Pandas, just now shown you guys, which is for 12 days will work. Data visualization, guys, 6 to 7 days we are going to work. Mainly, these are the topics actually, guys. Machine learning and deep learning. Machine learning and deep learning actually, guys. In machine learning, we have some around 31 sessions are there actually, guys. So all these are going to be my day-to-day schedule actually. So what is machine learning? Understanding machine learning use cases, process involved in the machine learning, types of learnings in machine learning, supervised and unsupervised learning. So just now, understanding the training and testing sets in ML. What is dependent, independent variables, splitting the data set into train and test sets. What are the different ML algorithms? What are classifications? What are regressions? All these completely day-to-day schedule actually, guys. Beyond accuracy, what we can do, sensitivity, specificity, and all these things, ROC and AUC scores, and what is going to be data sampling techniques are there, and improvement of model performance. In improvement model performance, guys, these are the methods. Hyperparameter tunings are there, grid size CV, randomized CV, random forest, ADA boost, gradient descendant. In deep learning, guys, we work all with this computer vision projects. So mainly we are going to work with the images actually, guys. So there are a lot of images are there. Opencv. 2 days we are going to work with the Opencv, guys, working with the images, how to read the images, how to display the images, how to understand the color spaces actually, RGB, grayscale images, image processing using NumPy, cropping of images. I think cropping of images actually, guys. There is a typo. Yeah. It's going to be cropping of images actually, guys. How to crop the images actually. So all these are going to be the applications actually, guys. Face expression recognition, using the FER library, which is going to be FER with a live webcam. We'll just run our live webcam, and we are going to identify what is the emotion of that particular in the live webcam is there. Images for deep learning. What are the different image data sets are there? Okay, implementing of MLPs, convolution neural networks, understanding of convolution neural networks, CNNs, autoencoders, TensorFlow. All these are going to be as part of. Even we are going to work with audios also, guys. So generally audios will not be discussed by most of them, but I'm going to give you some idea about how to work with the audio files, how the machines will learn from the audio files actually, guys, what they will learn, how they will do, what exactly we are going to be doing. NLP separately, guys. NLP, we are going to be having a separate concept is there. How to work with NLTK modules, bag of words. All these are going to be what we are going to be using actually, guys. RNNs, how to work with the RNNs in our NLPs, we are going to be working with them. Okay. The sentimental analysis, web scraping. These are all the particular libraries what we are going to be doing this actually, guys. Yes. Each and everything is a project only, guys.
And what about Hadoop and Spark?
Yes, even Hadoop and Spark is also there with us. So we are going to be discussing about the Spark framework we are going to be using, and we are going to be discussing about the basic. That means these are all as a full stack data science course. You should be knowing some other areas also, what exactly we are going to be covering. So that is going to be the part of our course. It is only just a 4 to 5 days actually, guys, not more than that.
Sir, projects are also available in
yes, it will be available. See, in every example, so project means, don't think that. So for every example we discuss, like for example, we are working with some kind of a KNN algorithm. So KNN case study. So we are applying some KNN algorithms with a real-time data sets actually. A decision trees is there. Applying the decision tree with the real data sets. So every algorithm we are going to be working with the real data sets only, guys. Navi-based case study, we are going to do one project. So every algorithm we are going to do a project separately along with these cases, along with the case studies in our classes also. We are also going to doing some additional projects also we are going to do. So 5 projects we are going to be discussing. That means depending on your interested domain, you can choose any one of that particular 5. That is up to your interest, how to handle that. So we are going to guide you to doing that particular project actually, how we are going to do that, to get some experience, to as part of interview point of view, how to solve your problem or what are the different questions that you are going to face. So end to end, guys, starting from the beginning, that means starting with the basic programming skills up to the deployment and all these concepts, along with the FAQs, resume preparations, everything we are going to be projects and all these things will be part of our course. 5 minutes. So guys, if you have any questions, guys, yeah.
Yeah, you mean at the end of this course, we will learn this entire course and we can try interviews?
Yes, yes, absolutely. Absolutely, you can do that.
Okay.
Absolutely, you can do that. It depends on your experience also. How much experience you are showing also, that depends on that. For example, if you are, let us say, if a person is a fresher, he really don't require to show all this expertise and all these things. At least some basic analytical skills, some basic ML knowledge, So they'll get some job opportunities. You already, freshers also getting a lot of job opportunities. So yesterday, one of my old student has called me from Orissa. So he has been appointed as a research associate. So for one company, he has got a job as a research associate actually. So it's basics, just like they have given some basic questions only, some just basic terminologies of ML, and they're given a small Python program and just ask you to write the program. That's it. It depends on your experience also. Okay.
Yeah, Vamsi.
Yes.
I have one question.
Yes.
Yeah. So see, my experience during the past few years has been to manage the cloud migration project.
Okay.
From the legacy data centers to the cloud environment.
Okay.
And also to do the OS upgrades for those same data centers. From 2008 to 2016. So now this skill, right? How I'm wondering, how can I integrate it with that experience while I do try for the jobs?
Okay. Basically, the thing is, I think you are not involved in any data analytics. You're only involved in the data migration only.
Data and application migration as well as the infrastructure.
Okay. That means you don't have any exposure to the data and all that applications, right? As of my knowledge. Yeah. Basically, your experience is not about the data. Though you have been working with the data centers and all these things also, you don't have any exposure to the data. So basically how the data will be there, what are the data structures will be there. You need not to worry about that. Just only the thing is you have to dump the data or just we have to migrate the databases.
Correct. Yeah, this is what we do.
So that is what you do that. So now this is going to be a little bit different from that. That means you're going into the data actually. You're just going into the data actually. And even you can also, that means you may have some kind of an analytics on your, so as part of your experience, I can say that. So let us say that if this is the size of the data, so this is going to be the type of the migration. So how much time it is going to take? If this is the data, if this is the type of the migration, how much time it is going to take? Your past experience is there, right?
Yeah.
So you have obviously maintains that all that particular analytics part. So how much time it has been taken? So what is the issues you have been got? Something like that. So same data, that means the data may be not that much used data, but I'm saying that in terms of that. So how much time it may take for the next migration actually? So when could I expect the next migrations? So such kind of an analytics and predictions can be done with the help of this one. That is one area which you can integrate with your current project. Okay. Or else show it as a separate skill, not integrating with your current project, but you can just show like something like from last 2 years, I'm working on the data science.
Okay.
Where you are going to show the expertise on the data, but not on the data migration.
Okay. And how about like earlier, right? I do had, but that was actually quite around 9 years back. I had experience in SAP BI and SAP CRM. So So at the time, how advanced was this field, or like how was it at the time?
Yeah. Even because I also have an experience in BI. I worked with the Microsoft Business Intelligence. It may be some around same time, 10 years before.
Yeah, right.
So SAP BI. So my complete 18 years of experience is related to BI only. This data related technologies only, basically. So that is easy for me. That means as a business intelligence, as a business BI specialist, because in BI, what generally we do is we analyze only the business data. And there, as a BI developer, we are not interested in doing the analysis. So some other business users require some reports or they require some kind of a systems. We are preparing the system for them, but we are not consuming them actually. We are not using them actually in BI. Okay. And one more thing is in BI, it only tells you about something like what has been happened, but it can't do some kind of a prediction actually.
Correct.
Here we are going to do some kind of a predictions, and the way we use this different actually. There we are having something like dimension tables, we have a fact tables, and summarizations are like average, sum, etc. Here it is how is the data only we are trying to study. The patterns we are identifying this. You can imagine like as a data mining. You can just imagine like a data mining beyond the data mining actually. And that too, they works only with the structured data. But here we are going to work with unstructured data as we are going to work.
All right.
As I told you, images are there. You cannot do any analysis on the images by using that one. But here it's a different case actually. Some kind of a patterns it will identify.
Earlier, we used to denormalize the data, right?
Obviously.
We used to denormalize and then so here it is not about normalization.
No, it's not about a normalization or anything. It's not related. We identify that. We are making the machines to identify the patterns.
Okay.
So we are not doing any.
Identify if the data is normalized or denormalized.
No, it's not a matter at all. It's not a process at all. We just directly understand the issues with the data, and we are going to just give the data to the machine, and then machines will start learning from the data.
Okay. So then I think that what makes sense is for me to get into this is like, as I said, right, for the cloud migrations of the servers, application, and the data.
Yes.
That I think I can integrate it by saying that, we have for after each and every migration, we have used this machine learning to understand the earlier migration pattern and get suggestions from the machine, right?
Obviously. Yes. And based on that, you can predict what could be the feature also. What could be the feature migrations also, we can identify them. So expecting, like in the future, what could be the next migration we have to do? That is what we have to verify that, what we can do then. So now everything is going to be an automated system. Like when could be the next migration we have to do? So machine will recommend you.
Okay.
So from the past patterns, whatever you have been done.
Yeah. Okay. Sorry to interrupt.
Sure. Go ahead.
Then on that one, right? For this making this prediction, now we have to use Python to
R
to write the code, right? To write the code and then using the libraries, right?
Obviously.
Okay, using the libraries, and then it will. And obviously we have to feed the data, right?
That's it. We have to just feed. Yes, we have to feed the data. So this is my input. This is an output. Study it. But how much effectively it's studied on all these things, we have to verify them.
Okay. Yeah. Thanks for that.
Thank you. Yeah. Fine.
Vamsi, one question. So
yes.
Are we going to work on 3D models apart from image processing and all? For example, image processing, apart from image processing, like, are we going to work on 3D models like AutoCAD models?
Yes,
kind of things to identify?
You're talking about auto decoders, right?
No. Like, for example, if you see the AutoCAD, we can design some 3D models like buildings and structures and all.
Okay.
So is it possible to?
We can do that, but there are very higher level as part of this, as a higher level. So they are what we call it as auto encoders here now.
Okay.
So we do some kind of an auto encoders. We have some introduction related to auto encoders, but we don't go into that particular auto encoders because there is a little bit a research level. Deep learning is like something like a research level we have to do. So whatever the basics things that are required and whatever that particular the utilities and functionalities you require to understand a deep learning, that is all we are going to be learning here as part of the class. So after that, your requirement changes. Somebody wants to work with some kind of an application. Somebody wants to use another applications. So the particular requirement changes. According to that, they have to move towards them. But as of my understanding is, whatever you require is going to be auto encoders. So the machines can draw the designs actually. The machines can draw that. For example, if I give some 10 dog images and if you train the machine can draw a new dog image.
Okay.
So that is an auto encoders, what we call it as. For that, we have some introduction is there for that, but not in depth about it. Okay.
Yeah.
Fine. Yes, guys. And somebody is asking, sir, what about the maths? Venkatesh. Yes, absolutely. As already I told in our example also shown you, there is an entropy concept is there. So we are going to learn that the maths behind that particular algorithms, which are going to be as part of our course curriculum. So whatever the maths and stats that is required, we are going to be using them actually. Okay, fine. So yes, Bharat Kumar, sir, I'm Bharat. I'm completed MTech in 2009. Up to now, I'm teaching field. I want to move industry. Yes, absolutely, guys. So as I told you, anybody, even I don't know. I think some name yesterday somebody has called me. His name is I didn't remember. I think Venkatesh. Is anybody there? Venkatesh today? Yeah, Venkatesh. I think have you discussed yesterday? Have you called me yesterday? Yesterday I have been discussing with one of the person actually, guys. He is a mathematician actually. So he was working as a mathematics lecturer, but he is having some good knowledge of all the maths and all these things. So, but he does not have any programmatical skills. So being you are in the teaching side. So Bharat Kumar, so being you are already in the teaching side, maybe I don't know what is your specialization actually. So in which branch you are working, Bharat?
The computer science.
Okay, you are computer science only, so not a problem. You can just easily you can learn the course actually, not a problem at all. So only thing is moving the industry, that is slightly, it is going to be a little bit difficulty for you, because you have to show some around 9 years is there. So out of the 9 years, you can't show the total 9 years as a fake experience in the industry. So in that cases, what you have to do is some around 5 years as a teaching and a 3 years as in this one, something like that. You have to do the adjustment actually, because you cannot show all the 9 years of experience.
Okay, sir. Okay.
Tomorrow class is there for Python or?
Tomorrow also, maybe maximum I'll start with some introductions, like not Python tomorrow, but I just start with some basic introductions, like what environment we are going to work. So those are the things, just will give some idea about them. And maximum from maybe tomorrow is a Friday. So tomorrow is a Thursday. Okay. So maybe, okay. Tomorrow we'll take another demo class actually, guys. Just a conclusions and some extensions of that. And then maximum from Friday onwards, I'll start with the introduction to Python actually.
Okay.
Okay.
Hello, sir.
Yeah.
Hello, sir. It's Swastik here.
Yeah, Swastik.
Yeah, sir. Actually, currently I'm having total 5 years of experience in cards and payments domain. Mainly we work on the credit card area.
Okay.
So, and my current technology is mainframe. So, sir, what are the prerequisites of this course?
There is nothing prerequisites are there actually. It's not a programming language. As I told you, there is going to be some maths and stats behind them.
Okay.
You have to understand the mathematical background behind that algorithm, how it is working. That is what we have to study. Implement. You have seen the code today, no? How we're not writing any code actually. Functional code, we don't write it. There is some functions will be there. We have to just call them and we have to use them. That's it. So there is no prerequisites. Anybody who is having an interest to work with the data, there must be some interest to work with the data. Mainly we work with the data. Don't expect like a programming language, we'll write a program and get the results. No, everything is working with the data, because some people don't like to work with the data at all. So if you are having an interest to work with the data, everything should be working with the data only. If you are having the interest, you are suitable for this particular data science learning.
Yeah. Thank you, sir.
Okay, fine.
This class is from Monday to Friday or?
Monday to Saturday.
Okay.
Yeah. Yes. Yeah. Guniraju. So you can just, if you want to talk me to personally, no worry. No worry. My backend team will call you. Will get back to you. So just they inform that. Just you please inform them that you want to talk to me personally. So they'll connect their calls actually. Because currently we don't give our numbers actually. We don't give our contact numbers. But once the batch was started, we are going to share our contact numbers. We need not to share. We are going to create a Telegram group. We will create it. So we are there in the group. You can discuss with me. Okay.
Yes, sir. Thank you.
So my backend team will get back to you. Just inform them that you want to talk to me personally. They will connect the call.
Okay, sir.
Okay. Fine. Thank you all of you guys for today. Fine. Thank you all of you guys. Hope all of you, we see you all of you tomorrow, same time at morning 8 a.m. Same link actually, guys. Thanks a lot. And we'll meet in the tomorrow's class. Have a nice day, all of you guys. Thank you.